fellow teachers and students. Good morning, class. Okay, thank you. You may sit down. All right. In our last lesson, we had a look at the forces between molecules of liquids, and we also had a look at molecules of liquids, or forces that are acting between molecules of liquids and also the molecules of whatever container or container they're in. Now in this lesson we'll be basically looking at the volume of object, and we'll be looking at measuring the volume of regular and irregular object. Now looking at a square prism, right, it is a regular object, so we can simply measure the volume by using the length times width times height, or basically all this length, width and height all comes in one dimension, that is the meters, or the length. We're trying to measure the length of the highest part, the width, and also the now looking at the volume of irregular object, how do we measure that? There are some ways in which we can measure, and that is the displacement method. We can displace the volume of liquids and then measure by using the measuring cylinder. Now in this lesson, the topic will be basically on measuring the volume of regular and irregular object. Looking at how we can measure the volume of this regular and looking at these ones, anyway, you will find that in measuring the volume of this regular object, you will find there are three of the dimensions that you will have to use. You use the length, the width, and the height. Those are basics: length times length times length, and then you have the volume in length cube or meters cube. That is how you can measure. You knew how you can measure that. Moving on to the next. I will now ask you to go through and then measure the volume of some of the objects which are on a table here. You'll find that they are irregular, meaning that they are not straight. You cannot simply measure the length times width and also the height. And therefore, I will leave these ones in here. I will pass you these measuring cylinders, and then you can measure the volume of this object. I will have two measuring cylinders at this desk. You can pass one over. Those people over there, at the back, you can use this. This is what you can use to measure. For your group, you loads can measure, say this one, and I will have to pass this one for that group. You two decide. One can go over there, one come over here. Where is the stone that I stay? Firstly, you have to tie the rope, or let's say that stone to the rope, and then you carefully put it into the measuring cylinder, and then you take the reading. The instructions are given here. You have to partly fill the measuring cylinder and note the reading. Remember to read the mark at the bottom of the meniscus, and then you gently lower the stone into the water and note the new reading. The difference is the volume of the stone. Right, has everybody taken the reading of the note yet? Okay, now on to the activity or the questions. Right, for this, you quickly take down the notes of this and then I'll give you the questions that will come after. Okay, pilot teachers, you can also ask your students to take down the notes after taking the reading from that or measuring the volume of the object. Right, for that information you'll find that for okay, it is not lake object, it is for larger objects, okay, LARGER, and overflow can be used, right? The can is filled to a spout and then before the object is gently lowered, you find that the volume of the water that overflows into the cylinder is the volume of the object. So simply, if you don't use if you can use a measuring cylinder as well as a overflow or overflow can, you can simply measure the volume of that. So simply when you lower that larger object into the overflow can, and then the water will have to fill into that cylinder, and the reading that you take from that will be the volume of that object. I quickly have this information. I'll give you the questions that follows for that little experiment. All right, if you look to the board, there is something like an overflow can is something like this. So when you lower the stone into the liquid, you'll find that it will lead to where the water will fall into that measuring cylinder. So you cut this one, and that gives you the volume of this stone. But otherwise, you can use the measuring cylinder to measure the volume of the object or that irregular object. All right, here are the questions. Okay, what is the volume of that object that you measured, and how do you measure the volume of the stone if you have or only have a beaker. All right, for question number 1, I think you have taken the reading for that. For question number 2, you can discuss that. How do you measure the volume of the stone if you only have a beaker of water? How do you measure that? Okay, we will quickly go through the questions and how you, or what is the reading that you've taken from measuring the stone. Right, for the first one, what is the volume of the object that you measured? Right. Rachel, you give us the volume of the object that you measured. Okay. Right, stand up.
The volume of the stone that we measured is 16 milliliters or 16 square centimeters.
16 milliliters or 16 square centimeters. Okay. Jolene, you help her. She is saying 16 square centimeters. Is it correct? Okay, very good. So it is not 16 square centimeters, right? The volume, if it is in milliliters, simply 1 milliliter is simply equal to, okay, 1 cubic centimeter, or not centimeter, but it is, okay, 1 milliliter is equal to 1 cubic centimeter. So in here, they measure the volume of this object to be 16 milliliters, and therefore it should be 16 cubic centimeters. Good. Right, we'll have the next group to give you reading. Okay, Kimberly.
Cubic centimeter.
12. Okay. The reading is, or the measurement for the volume of that object was 12 milliliters, and therefore it should be 12 cubic centimeters. Now, Ume, if you decide to measure the density of that object, how do you measure? Okay, Ruli, you help Ume to answer that question. If you decide to measure the density of that 12 cubic centimeter object, how do you measure that?
If you wanted to find the density, density equals mass over volume, so you get the mass of the object and you divide it by the volume.
Okay, good. All right. We will only find the density if we have to use the formula density, which is equal to mass over the volume. How do we find out the mass? Enara, you tell us how we can find the mass of this object. If it was 12 cubic centimeters, what is the mass? Or how can we take the mass?
To find the density, mass of the object, you get the density multiplied by the volume.
Okay. You get density and then multiply by the volume. But in here, okay, you can do that. But firstly, how do you find the mass? How do you recognize the mass of that? Because we are saying that density, if you want to find the density, it is mass over the volume. But this time you have not found the density, and you are trying to find out the mass. That is what the question is asking. So how do you find the mass? Okay, pass it to Charlton.
To find the mass of the object, you divide the weight over the acceleration due to gravity, which is 10.
All right, okay. You learned in your last lesson that the amount of water that is displaced is equal to the weight of the object. So that liquid, how do you measure? So that means the mass of this liquid is the same as the mass of the object. Now taking the mass, you can use that on a scale. A scale can easily give you the mass in kilograms. And that can be used to calculate the density of the object. All right, based on that volume, that is 12 cubic centimeters, how do you measure that in its SI units? Okay, for the last group there. Solomon, you tell us how you can measure, or how do you change this into its SI units of density. All right, you are trying to find the density, and that the volume that this group has taken is about 12 cubic centimeters. But then you're trying to find density. How can you change that to its SI units? All right, you can stand up. All right, quickly. Okay. Don't worry if you have to make mistakes. Just give us what you think.
Divide the mass, which is kilograms, kilograms on volume, which is meters cubed, to get kilograms per
Okay,
cubic
very good.
meters.
So you find that the mass can be used or measured in kilograms. That is in SI units, and you find the volume will be in cubic meters. Now also, you can use other smaller units that are the grams and also the cubic centimeters. But it is more convenient that every time you have to put these answers in the SI units. Anyway, this brings us to the end of the lesson. I'll quickly go through and then summarize everything. Right, firstly, you find it when you're trying to measure the volume of regular object, you can use length times width times height. Those are the three of the dimensions that you can use. Now all of these dimensions are in length, and they have a unit which is the meters. And then if you are trying to measure the volume of irregular object, you can simply use the decanting method or simply displacement method, meaning that the amount of water that is displaced can be the volume of the object. Okay, that can be done using a measuring cylinder. If you don't have a measuring cylinder, you can simply use a bigger tube, or let's say an overflow can. The amount of water that is displaced, and then when it overflows to a measuring cylinder, you take the reading. That is simply the amount of water, let's say the volume of that irregular object. Also, you can find out the density of the object by getting the mass of that and then dividing that by the volume. Okay, that is the end of the lesson. Right, our keyword for today is volume. Good afternoon, pilot teachers and students. Good afternoon, class.